All right, today we are looking at modeling with systems of equations, notes. Our learning targets today are that we will be able to write a system of equations given a situation. We will be able to solve the system of equations that we created, that we will be able to state the solution of the system in terms of the given problem. Okay, so really what this means is that in addition to what we have already learned about solving systems of equations by graphing, by substituting, and by eliminating, now we're going to take what we've already learned and apply that to real world situations. So now, instead of having the equations given to us and we just solve them, we need to read a real world problem, write the equations for that problem, solve the equations, and then understand what the solutions to those equations mean, okay? So when we are looking at problems, we have to be careful that we are defining the variables, writing the equations correctly, solving the systems, and then answering the questions in the context of the word problem and understanding what those solutions mean. So example 1, 250 students went on a field trip. They went either on a bus, which holds 43 students, or a van, so there's a combination of buses and vans transporting students. So they went on a bus, which holds 43 students, or on a van, which holds 13 students. There were 10 drivers available. All drivers were used. I'm going to add that in. All 10 people drove. There were 10 drivers available to drive the buses and vans. How many buses were used? How many vans were used? So we'll define our variables B for bus and V for van. Okay, and then we're going to be writing two separate equations. Okay, we have two variables. We need to have two equations in order to solve a two variable word problem. All right, so the first equation that we're going to write is going to be about the number of vehicles. Okay, so the first equation, number of vehicles. So equation 1. And then the second equation is going to be about the number of students, okay? And that's helpful to establish first, so you understand, well, what am I trying to write about? So first of all, we know there were 10 drivers available, and I just added in to tell you that every driver who was available did drive. So the number of drivers who drove buses plus the number of drivers who drove vans is equal to 10. And you'll happen to notice that for a lot of story problems, real world applications / modeling, whatever you want to call it, when we're writing linear equations, these a lot of times are written in standard form, okay, because it's part plus part equals whole. And this is just a really good way of representing a lot of situations where we have two different things that we're analyzing. Okay, so that's our first equation, number of vehicles. Buses plus vans is equal to 10. And then our second equation is about the number of students. All right, so we know there were 250 students total. So I'm going to add in that word total. So each bus would hold 43 students. Each van could hold 13 students. I'm just going to add that there. I know it's on the next line, but just so it's together. I just added students there. So 43 students per bus, 43 students times the number of buses, plus 13 students per van, so 13 times V, 13 students times the number of vans, would equal 250 students. Okay, so that's great. I'm going to go ahead and take a look at these two equations and decide how I want to solve these equations. I'll probably use elimination. So they're already lined up. They're both in standard form. The B's line up, the B's line up, the equals line up, the integers line up. So it's really nicely set up for solving using elimination. So this is 43B and B. 43 is a prime number, so the greatest least common multiple is just 1 here. especially with the coefficient of 1. So I'm going to cancel out the v's since I can multiply by 13 here. So I'm going to go ahead and take my top equation. If I want to cancel out the v's using elimination, I'll take my top equation and multiply it by negative 13 so that my v's will cancel out. So my top equation is going to get multiplied by negative 13. I'll bring it over here. My bottom equation, I'm just going to bring it over because I already have that positive 13b. So this one just gets brought over. So again, my top equation, everything is being multiplied by negative 13. So negative 13b minus 13b equals negative 130. Okay, this equation, I'm just bringing it right over. 43b plus 13b equals 250. Okay, so then I go ahead and I add these two equations together. 43b minus 13b is 30b. My b's canceled out just like I planned. I'm going to zoom in on this part of the problem. So this is the elimination that I planned. That worked out great. Then I bring down my equal sign. And this is going to be 120. 250 minus 130 is 120. Then I divide each side by 30. 30 divided by 30 is 1. So b equals 4. All right, then once I know b equals 4, I can plug that into either one of my original equations to get b. So b plus b equals 10. I know b equals 4. So 4 plus b equals 10. Subtract 4 from each side, and I get b equals 6. Okay, so the group took 4 buses and 6 vans. 4 buses and 6 vans. Okay, and then I can just do a quick check step to make sure that this is correct. Buses is 4 plus 6 for vans equals 10. That checks out. And then for my number of students, I can just check that out as well. I'll do that very quickly here. 43 times b was 4. So 43 times 4 plus, then remember vans was 6. So 13 times 6. And that should equal 250 plus 13 students per van times 6 vans. And then if that equals 250, both equations checked out in my check step. And that does equal 250. So we were able to check that out. So this group took 4 buses and 6 vans on their field trip. Okay, next, example 2. See if I can get zoomed out a little bit. Okay, students. Sorry, I need to zoom out just a little bit more. Okay, that's as far as it's gonna go there. Students were selling, there we go, that's a little better. Students were selling paperback and hardcover books for a fundraiser. They sold a total of 234 books, okay? Paperback books were $1.50, hardcover books were $3. They raised $426. How many of each hardcover and paperback books were sold? All right, so let's go ahead and define our variables. So P is for paperback, H is for hardcovers. Okay, they sold a total of 234 books. So I know I'm going to be writing one equation about the number of books, and they raised $426. So I know I'm going to be writing another equation about the money earned, okay? So one equation is going to be about number of books sold. And the other equation is going to be about the amount of money raised. Okay, so the number of books sold was 234 books. So I can say paperbacks, the number, if this is the number of paperbacks and number of hardcovers that we're representing over there. All right, so my first equation is going to be about the number of books sold. So I can say paperbacks plus hardcovers equals 234, because that's the number of books sold. And I spaced that out a little bit because I know the next equation is going to have money. It's going to take a little more space. Paperback books sold for $1.50 each. So $1.50 per paperback plus $3 per hardcover. And they raised a total of $426. Okay, so those are my two equations. That's the hardest part, is getting the two equations out of your story problem. So pulling those equations out. Great job with that. So now these are both in standard form. Standard form is really conducive to being solved with elimination. So I have a decimal here. I'm going to stay away from that if I can. I'm going to look at my h's. Yes, this has a positive 3h, so I just want to make this into a negative 3h. So I'll take my top equation and multiply it by -3 so that I can use elimination to eliminate the h's. So I'll distribute that -3 and write my new equation over here. This one is just going to get brought straight over. So -3 times p is -3p. -3 times h is -3h. -3 times 234 is -702. Okay, and this equation gets brought straight over. So 1.50p plus 3h equals 426. Okay, and then I add these two equations together. So -3p plus 1.50p. I have more negatives than positives, so I know my answer is negative. And then $3 minus $1.50 would be $1.50. So -1.50p, and then the h's will eliminate. This was my plan, so that worked out perfectly. 3h minus 3h is 0. Bring down the equal sign. -702 plus 426 is -276, right? So let's do 702 minus 426, yes, so -276. And then we'll divide each side by -1.50. A negative divided by negative is a positive, so I have p equals, negative divided by positive is a negative here. Oh, sorry, I'm dividing by a negative here also, so it's a positive, excuse me. So 276 divided by 1.5. 184. So the number of paperbacks sold was 184. And then I can plug that into my original equation and solve for the number of hardcovers. So paperbacks sold was 184. So 184 plus hardcovers. I'm taking this original equation and I'm rewriting it down here. 184 instead of p, because I just solved for that. Bring down the plus h, bring down the equals, 234. Then I subtract 184 from each side. Okay, this is 0, and 23 minus 18 is 5, so 50. So the number of hardcovers is equal to 50. So the students sold 50 hardcover books and 184 paperbacks. I'm going to go ahead and say paperbacks first because we did list that first. So the students sold 184 paperbacks and 50 hardcovers. Okay, and you can check that in both equations with your calculator to make sure that you have that correct. Let's go to example 3. The football players sold a total of 125 t-shirts and sweatshirts. So when I see the word total, that's my clue that I'm going to be writing an equation about that. And the t-shirts were $5 each, sweatshirts were $8 each. They made a total of $850. How many of each t-shirts and sweatshirts were sold? So, so let's call T number of t-shirts. Sorry, I started writing in cursive, so I finished. The reason I wrote a cursive T, I'm going to switch back to print because I know a lot of people like that. And then let's use W for sweatshirts. Because our S's can look like 5s and that can just throw us off. So we'll just use the second letter. So T for t-shirts, W for sweatshirts. The reason I use the cursive T is because, again, that manuscript T can look like a plus sign. So let's just not confuse the issue. The plus can look like a T and the S can look like a 5. So let's just use things that are going to make our math simpler. Why complicate things? Why leave room for error? Okay, so we sold a total of 125 t-shirts and sweatshirts. So if you're reading this carefully, you're getting the equation right from here. This is 125 is the total, so equals the total, equals 125 t-shirts plus sweatshirts. Okay, so there, if you read the problem carefully, a lot of times you can get the equation right there. And then they made a total of $850. So here's our other equation. Is going to be about money. So again, that first equation is going to be about items sold in number of items sold, to be more precise. And our second equation is going to be money raised, or a dollar amount in sales, or sales in dollars. Okay, total sales in dollars, to be a little more precise. Okay, so number of items sold, we already wrote that equation, but let's put it in standard form. So t-shirts plus sweatshirts equals 125. So we sold 125 items, and then our total sales were $850, with t-shirts costing $5 each and sweatshirts costing $8 each. So $5 times T, the number of t-shirts, plus $8 times W, the number of sweatshirts, equals $850 sold. All right, and then when I look at these, it's in standard, these are written in standard form, so that's really conducive to being solved using elimination. So I would rather work with 5s than 8s, so I'll try to cancel out my T's. And then I see this is a positive 5T. I want to make this into a negative 5T, which means my top equation can be multiplied by negative 5 to help me with elimination. And I'll write that right over here. So I'm distributing negative 5 over the equation, T plus W equals 125. So negative 5 times positive T is negative 5T. Negative 5 times positive W is minus 5W. And negative 5 times 125 positive is negative, okay? 5 times 25 is 125. 5 times 100 is 500, so 500, negative 625. All right. Then I'm just going to bring this equation straight over. 5t plus 8w equals 850. So 5t minus 5t, that cross cancels. 8w minus 5w is 3w. Equals 225. And then divide each side by 3. 3 divided by 3 is 1. And that's going to be 75. So W equals 75. So they sold 75 sweatshirts. And then I see, take my original equation, I can see that it's going to be 50 t-shirts because 50 plus 75 is going to give us 125. But let's put that in algebraically. So let's rewrite this equation. T plus, instead of W equals 125, we'll say 75. We're going to sub that in, substitute in 75, and then bring down the equals 125. All right, so t-shirts plus sweatshirts, which we just solved and said was 75, equals 125. So then we subtract 75 from each side, and we get the number of t-shirts equals 50. Okay, so the football players sold 50 t-shirts and 75 sweatshirts. And then you can check that in both of the original equations. We restated the, we always have to make sure that we are restating our answer in terms of the word problem. Okay, so you do need to give your answers in context. If you just say 50, 75, and then put a box around it, that's wrong. You will not get any credit for that. You do need to state your answer in the context of the story problem. All right, next, Mark. Mark sold 504 tickets for the school play. Adult tickets cost $5 and student tickets cost $3. Mark's sales totaled $2,090. How many adult tickets and how many student tickets did Mark sell? Excuse me for that sneeze. Okay, so there are two things happening here, number of tickets and the money sold. So those are our two equations that we'll be writing about so we can solve for our two unknowns. And first, let's go ahead and define our variables. Let's call A the number of adult tickets sold. Number of adult tickets. And S for, I'm going to use a cursive S just so it doesn't look like a 5, number of student tickets. All right, so our first equation is going to be about number of tickets. Okay, number of tickets sold. And the second equation is going to be about sales, okay, total sales in dollars. Okay, so first of all, let's look at the number of tickets sold. They told us that Mark sold 504 tickets. So this is going to be the number of adult tickets plus the number of student tickets will equal 504. And then, so the second equation is about our total sales in dollars. Adult tickets were $5 each. So we'll say $5 per ticket times A, the number of adult tickets, plus our student tickets, which were $3 each. So $3 per ticket times S, the number of student tickets, will equal our ticket sales, 2,090. Okay, and again, with a lot of our story problems, we're looking at part part whole, part whole. So we will be using a lot of standard form when we get to solving systems of equations with word problems, and elimination is just really helpful with that. I have 5a and 3s, so I'll try to cancel out the s's just because 3 is a little smaller than 5. That'll keep my numbers a little bit smaller. So this is a positive 3s, so let's leave it alone. Since I'm already manipulating this equation, let's multiply the top equation by negative 3 to cancel out the s's. So times negative 3. Okay, so we'll distribute the negative 3. So negative 3a minus 3s equals negative 115, 12, right? No, that's not right. 504 times 3. Yeah. Okay, so then negative 1,512. So then we'll bring this one straight over. 5a plus 3s equals 2,090. Okay, so I'm sorry, I was off the screen a little bit there. So then let's go ahead and add these two equations together. 5a minus 3a is 2a. Negative 3s plus 3s, those cancel out. 2,090 minus 512 is 578. So we have 2a equals 578. We'll divide each side by 2 to get a equals 578 divided by 2 is 289. Okay, so there were 289 adult tickets sold. So let's take this top equation, a plus s equals 504. We'll set the a equal to 289 plus s equals 504. Subtract 289 from each side, and we get s equals 504 minus 289 is 215. And then, so this means we sold 289 adult tickets and 215 student tickets. Okay, so Mark sold 289 adult tickets and 215, sorry, that was off the camera there, and 215 student tickets. Okay, and then we can check that. So this worked out, 289 plus, we'll do our check steps with the calculator real quick here. 289 plus 215, that equals 504. So this equation checks out. Here's our second equation, 5a plus 3s equals 290. So we'll plug that in. 5 times a, which was 289 adult tickets, plus $3 per student tickets, which we said we had 215 student tickets. Okay, so we're doing, again, this is our check step, $5 per adult ticket at 289 adult tickets, 289 adult tickets, plus $3 per student ticket at 215 student tickets, 215. And this should equal 2,090, our total ticket sales. So when we check both equations, we know that we have solved this correctly. Okay, so he sold 289 adult tickets and 215 student tickets. All right, example, whatever we're on now, graphic. All right, so yesterday, Rapids Bakery sold several gourmet bagels at $2 each and a few cakes, chocolate cakes at $8 each. The difference in the number of bagels and the number of cakes sold is 21. So we know, so first of all, let's do B for bagels and C for cakes. B equals number of bagels C equals number of cakes. All right, and we know that difference, and that difference means subtract in a word problem. So we are told that he sold several gourmet bagels and a few chocolate cakes, and that the difference in the number of bagels and the number of cakes sold is 21. So they sold more bagels than cake, and they sold 21 more bagels than cakes. So the first equation is going to be about items sold. Okay, and then the total sales of bagels and cakes for the day was $132. Find out how many bagels and cakes were sold. All right, so the total was $132. Okay, so let's go ahead and write our second equation about money in sales. And that's in dollars. Okay. So our equation about the number of items sold, let's be a little more specific, number of items sold, and then money in sales, or sales in dollars, whichever way you want to phrase that. So more bagels than cakes, so bagels minus cakes, and then how many more? 21 was the difference, okay? So that's from this sentence right here. The difference in the number of bagels and the number of cakes sold is 21. And we know that the bagels have to be first for a couple of different ways. Number one, this sentence. The difference in bagels and cakes is 21. B minus C is 21. And in subtraction, order does matter. And then it's reinforced here because up here they also tell us several bagels, but only a few cakes. So we know there were more bagels than cakes. So it has to be bagels minus cakes equals 21. And then our next equation is going to be about money. So bagels were $2 each, cakes were $8 each. Okay, so $2 per bagel plus $8 per cake gave us our total in sales, $132. Okay, so now I want to use, because these are both in standard form is really easily solved with elimination. I'm going to try to eliminate my B variables because I'd rather work with 2B and negative 2B than 8C and negative 8C. So to keep my numbers a little smaller. Okay, so this is a positive 2B. I'll leave that alone as it is. I want to make this into a negative 2B. So this entire equation is going to get multiplied by negative 2. And then we'll rewrite it over here. So everything gets multiplied by negative 2. Negative 2B. Negative 2 times a negative C is a plus 2C. And then negative 2 times positive 21 is negative 42. All right, and then this one, I'll bring it over just like it is. 2B plus 8C equals 132. All right, so then I can go ahead and solve using elimination. 2B minus 2B is 0, those cancel out. 2C plus 8C is 10C. 132 minus 42 is 90. Okay, so this is just look at it upside down. 132 minus 42. And then divide each side by 10 to get C equals 9. So Rapid sold 9 cakes. All right, and then I can go to this original equation. B, I'm going to just draw an arrow so you know where I'm getting that from. My original equation was B minus C equals 21. And now that I know C is 21, I'm just going to take that and I'm going to, or excuse me, C is 9. I'm just going to plug that in here. So B minus 9 equals 21. And then I want to add 9 to each side to get B equals 30. So Rapid sold 30 bagels and 9 chocolate cakes. Okay, and then I want to check that and make sure that my answer is correct. So in my first equation, bagels minus cakes has to equal 21. 30 minus 9, that does equal 21. We can do that with mental math. Let's take our second equation. $2 per bagel at 30 bagels. So $2 per bagel times 30 bagels plus, oops, I was off the screen there. Okay, there's a little less clear there. So $2 per bagel at 30 bagels plus $8 per chocolate cake at 9 chocolate cakes. So $8, and we sold 9 chocolate cakes. And if this equals $132, then our check step is correct. Okay, so that's 132. So that checks out for both equations. If that didn't check out, we would need to start over. First, I would double check my arithmetic and work with the integers. Okay, so a lot of times it's just for you do all the beautiful algebra correctly, and then I see students making mistakes with just the basic arithmetic. So first, before you erase anything or get frustrated, just go back and check your arithmetic, because mostly that's what I see, where I see you making your mistakes, especially when it comes to integers. So just double check your arithmetic first, and then if that doesn't check out, then go back and look at your structure and how you set up your equations, because you have been doing a really good job with your equations. All right, next. We're almost done, hang in there. All right, a website allows users to download individual songs or an entire album. All individual songs cost the same to download, and all albums cost the same to download. Ryan pays $14.94 to download 5 individual songs in 1 album. Seth pays $22.95 to download 3 individual songs in 2 albums. How much does the website charge to download a song? How much does it charge to download an entire album? All right, so let's take a look at let's identify our variables, and then let's write our 2 equations. So let's do S for number of songs. Sorry, songs. Number of songs, to be more precise. And then A for number of albums. All right, and then we're going to be writing 2 different equations. We're going to be writing 1 equation for Ryan and 1 equation for Seth, okay? So let's talk about Ryan first. All right, so Ryan pays $14.94 to download 5 songs and 1 album. Okay, so Ryan downloaded 5 songs, and so that's my plus, 1 album, and he spent a total of $14.94. Seth paid a total of $22.95 to download 3 songs and 2 albums. Okay, so those are our 2 equations, all right? And then we'll just go back and double check in our word problem before we start solving. Ryan paid a total of $14.94 to download 5 songs and 1 album. Seth paid $22.95 to download 3 songs and 2 albums. Great. So then we have enough information. We have 2 equations. We have 2 unknown variables. So that's enough for us to solve. So I'm going to use elimination. This is already really nicely set up for elimination. The S's are lined up, our A's are lined up, our equal signs are lined up, and our totals, our integers are lined up as well. So I'm going to take my top equation. This is a positive 2a. I'm going to multiply this top equation by negative 2 so that this becomes a negative 2a. Okay, so everything here gets multiplied by negative 2. So negative 2 times 5s is negative 10 S. Negative 2 times positive A is minus 2A. And $14.94 times 2. Negative 2 is negative 29.88. All right, and then, so everything in this top equation just got multiplied by negative 2. My bottom equation, I'm bringing straight over, 3s plus 2a equals 22.95. So now I'm all set up for eliminating the a variables. Negative 10s plus 3s is negative 7s. Negative 2a plus 2a is 0. Bring down the equal sign, and negative 29.88 plus 22.95 is negative 6.93. All right, and then I'll divide each side by negative 7 to get s equals 99 cents. So each song is 99 cents. All right, and then just a reminder, the dollar sign always, in the United States, the dollar sign always goes before the monetary value. This is important because when we're reading something, we want to know that we're going to, how we're going to pronounce this when we're reading it. And if I start with if I had the dollar sign here at the end, I would start reading it left to right because that's how we read in the United States. And I would say 99 hundredths, then I would get to the dollar sign. And then I would realize that I'm looking at dollars. In countries where they read from right to left, they put the dollar sign on the right because you want to be notified right away that you're using the dollar sign. So, and that may be an overgeneralization, but the reason we have it here is because we want to know that we're reading this as 99 cents. Okay, so when I see that dollar sign and a 0 point, I know I'm going to be saying 99 cents, excuse me, I won't be saying 99 hundredths, okay? Also, like if I had a dollar amount, like $5.94, all right? If I had the dollar sign here, I would start reading this 5 94 hundredths. Okay, but then I would get to the dollar sign and I'd say, okay, $5 and $94? No. So we want to make sure that our reader knows at the beginning that it's going to be money. So here I would read this as 5 and 94 hundredths. So when I read this decimal is read as and, okay, before I get to that dollar sign. When I read it and I see from the beginning that I'm talking about money, when I pronounce this decimal, I'm going to say dollars and. Okay, because that divides my denominations from dollars to cents. So I'd say 5, this gets pronounced as dollars and, okay, so $5 and is how I pronounce this decimal, 94 cents. So it does matter, okay, it just makes our reading more fluent, all right, and plus it lets everybody know that you're intelligent enough to know that the dollar sign goes first. Is it a huge deal? Okay. No, but it does make things just a little bit streamlined. All right, so then we know that songs are 99 cents each. Okay, next let's talk about the number of albums. So I'm just going to sub this 99 cents into either one of the equations. I'll take the top equation. It does not matter. So 5s, but instead of s, I'll say 99 hundredths plus a equals 14.94. Okay. All right, so 99 cents 5 times, it's going to give us $4.95 plus a equals 14.94. Okay, and then $14.94 minus $4.95 is $9.99. So albums equal $9.99. Okay, so then we are required to give our answer in the context of the question. So this asked, how much does it cost to download an entire album? How much does it cost to download a song? So to download, it costs 99 cents to download a song and $9.99 to download an album. All right, and our last problem. The rectangle has a perimeter of 14 feet. Let me adjust this a little bit, sorry. All right, that's a little bit better. The rectangle has a perimeter of 14 feet. Sorry, I'm gonna adjust that once more, good. All right, and twice its length, L, is equal to 1 less than 4 times its width, W. Write and solve a system of linear equations to find the length and width of the rectangle. All right, so we know that the perimeter is 14 feet. And then we know that we have this, see, that's our first equation. It's gonna be about the perimeter. And our second equation is going to be about, so this is the total perimeter. And the second equation is just going to be about the relationship between the length and the width. So length and width relationship. Okay, and identifying our variables, L stands for length and W stands for width. And I just used a cursive L so it doesn't look like a number 1. Okay, so our total perimeter, we know the perimeter is equal to all the sides added together. So length plus width, or to shorten it up, 2 lengths plus 2 widths equals our perimeter, which is 14. Okay, and then our second equation is given to us in the word problem. So if we read this carefully, we can see it right here. Twice the length is equal to 1 less than 4 times the width. So here's the equation right here. Twice the length, L, is equal to, so 2L is equal to, so equals 1 less than 4 times the width. Okay, so I can't, to get 1 less than something, I have to start off with that something. Here's the something. 1 less than 4W. So we say 4W minus 1. Okay, again, I'm going to say that. So it's equal to 1 less than what? 1 less than 4W. So it's 4W minus 1. So here's our second equation, and this is not in standard form. Okay, so we took this directly from the word problem. So this is not going to be as conducive to solving with elimination. So here's my second equation. 2L equals 4W minus 1. Okay, and so I'm going to go ahead and solve with probably, so this L is almost isolated, so I'm going to probably use substitution. No, I think I'm just going to rewrite this into standard form, that second one, okay? So this first equation, I'm going to leave it as it is in a moment, so I'm going to come back to that. The second one, I'm just going to rewrite it so it is in standard form, so I'll subtract 4W from this side, subtract 4W from this side, so now I have 2L minus 4W equals -1. So I just took this equation and I rewrote it in standard form, okay? So now I'll take this equation and just write it underneath, and multiply it by -1. Okay, so that my 2L and 2, well, first I'll write it underneath. I'll do one step at a time. 2L plus 2W equals 14. Okay, so the second equation, I just rewrote it in standard form. Here it is. The first equation, I just copied it down. So now it's on the bottom, but it's the same equation. So now these are both in standard form. I want to have a positive 2L and a negative 2L, so I'll just take this top equation and multiply it by -1. So the top equation is now negative 2L plus 4W equals +1. The bottom equation, which was the original top equation, I'm just bringing it straight over. 2L plus 2W equals 14. Now I can add these up in the L. So we'll eliminate negative 2L plus 2L, cross cancels. 4W plus 2W is 6W. And 1 plus 14 is 15. Divide each side by 6. We get W equals 15 divided by 6 is 2.5. So my width is 2.5. And then once I know what my width is, I can plug that into, I can substitute that into either equation and solve for the length. So I'll take that top equation, since it's kind of right here, and I'll take this 2.5 and I'll sub it in here for W and solve. So 2L plus 2 times 2.5 equals 14. So 2L plus 5 equals 14. Subtract 5 from each side, which gives me 2L equals 9. Divide each side by 2 to get L equals 4.5. So my length is 4.5. Okay, and then I want to check that and make sure that it's correct. So 4.5 is my length. 4.5 plus 4.5 is 9. And then so I'm adding up the perimeter, right? The two lengths are 9. My width is 2.5, so 2.5 plus 2.5 is 5. 9 plus 5 is 14. So that satisfies my first equation. The perimeter is 14, okay? And then here's my second equation for my check step. 2 times the length, okay? So here, I'm just gonna write this one down because that's probably a little bit more than we wanna do mentally. 2L equals 4W minus 1. Okay, and if you can do that in your head, that's fine, or do it right in your calculator, that's fine. But for purposes of teaching it, I'm going to do each step. So 2 times L times equals 4 times W minus 1. So 2 times 4.5 is 9. 2.5, 4 times is 10. Bring down the minus 1. 10 minus 1 is 9. Okay, so that second equation also checks out. So the length of the rectangle was 4.5. The width of the rectangle is 2.5. So then again, we need to write our answer in context of the story problem. So the length of the rectangle is 4.5 feet. The width is 2.5 feet. All right, so again, we read that story problem, we identify our variables, we write equations to represent the situation, we solve for the variables, and then our last step is to state the solution in terms of the equation, or in terms of the word problem. So that is solving systems of equations with modeling.